Okay, so this is at the bottom of the syllabus, and it shows the format of how the course is going to be organized. So we meet on Tuesdays and Thursdays, and we're going to be doing quite different things on those 2 days. So Thursdays will be lecture, and Tuesdays will be lab. So we'll have 15 lectures and 15 labs. The lectures and each week will be a different topic. So we'll have a lecture on a topic and we'll have a lab on a topic. And I'll show you what those topics are in just a second. For the lectures, I'm going to describe the topic and it'll be a particular process. I'll give some applications, and then we'll talk about what the governing equations are for that particular process and parameters, some dimensionless numbers, scaling, idealized behaviors, that kind of stuff. Okay, so how the process works, and it'll be fairly broad and hopefully give you an idea about how things are working. Then there'll be a homework assignment, and the lab. Well, there'll be a homework assignment that will be the application of this particular process. And so, for each week, we've got a homework assignment where you're going to do a simulation related to a particular process. And so that'll be done at home or in the lab. That'll be hands-on setting up of an analysis. And the way that's done is I've made these videos that describe how to do the setup, give some overview of what the particular problem is, and give some some fairly detailed. In the beginning, we're going to be going just step by step, very detailed about how to set it all up. So that's stuff that you'll do on your own, and that's going to be that'll be the main way that we'll learn how to do these simulations. And then, so that'll be between Tuesday and Thursday, and then or between Thursday and Tuesday, and then on Tuesday, we'll meet in the computer lab, and this will be a meeting of the class. But what I want to do there is spend time reviewing the homework assignment, and if you have questions and problems, we can go over it there. If you have questions, though, as you're doing this, I would urge you to get in touch with me rather than waiting till Tuesday. Because what I would hope is by Tuesday, you've pretty much got things worked out. I don't want you just doing this, and if you encounter one problem, you stop and wait until Tuesday. So try to get things mostly worked out by Tuesday. But we can go over the assignment and talk about it. I also will have some other things to do in the lab. We can do some numerical experiments, for example. Once you've gone through and done this analysis and see how that works, we can do some variations on the analysis. We can build on that. There'll be some additional hands-on things that I'll show you about using the software and that sort of thing. So that's the basic overview of the course. So for each week, each one of these topics, we've got these two blocks of things that we're going to do. This stuff here, describing the process through the analytical solutions, that'll be what we'll do in the lecture. And then this stuff here will be the lab, and I really think of the lab as being some stuff that you do on your own. So the homework part of it, as well as when we meet here in the computer lab itself. So the lab part of it and the homework part of it will all be based on, it'll be based on solving problems Most of it will be using software. There also will be some aspects of the homework that will be based on what we talk about in the lecture. So the grade will have these different homeworks, and that'll be the main part of the grade, doing these different homework assignments. There also will be a project at the end where you'll do set up and do a simulation and present it to the class, that sort of thing, and that'll also be part of the grade. So the class is really based on doing these different problems. So that'll be that's going to be quite important. I guess one aspect is that there aren't any tests. So I don't know. Maybe that's good. Um, so yeah, but I guess one aspect of that is though because there are no tests and it's all based on this homework. If you just do the if you work it out, each homework is about 5% of the grade. So if you don't do a couple of the homeworks, you can get into some trouble pretty quickly. Um, so hopefully that's not going to be an issue. If you have some if there are some difficulties that happen in terms of getting the homeworks together, you should contact me as soon as you can about that and get something worked out. Um, I'm pretty easy to, I think, I'm pretty easy to contact by email. Um, if you send me an email and you don't hear back from me, like in a day, probably half a day, you can bug me again. It's no problem. I, I I'm I'm fine with that. If you haven't heard from me back in a day, then do send it again because I it may have gone. The Clemson has this email filter called Clutter on Outlook. I don't know if you guys have that on what you use, but they installed that on our email, and all kinds of stuff goes into Clutter. So not that I think you guys sending me email is clutter, but it does. Um, and yeah, when we did our field camp last year, everything everything from Canvas was going into Clutter when the course first started up. So I was thinking, hey, this is great. Nobody has any questions, but in fact they did. So anyway, feel free to bug me if you need to. Um, okay, so here are the topics that we're going to cover, broken down by week. And let's see. Uh, these are the main things: flow, reactions, transport, and deformation. And let's see. You can kind of see right here. These are the topics related to flow, and then we've got some reactions. And then once we get in here, this is all well. Here's a reaction. Here's another reaction. This is transport. This is flow. And then here, this is also transport, heat transport. Some more complicated flow stuff, and then the deformation is at the end of the class. Okay, so the way this is set up, here's the Thursday and here's the Tuesday. So for next Thursday, we're going to have a lecture on flow through porous media, and then there'll be a problem that involves setting up analysis of that, and we'll do some verification. Okay, and then the next week it's flow laminar. What that means is that you've got the first week will be flow through porous media, and then the second week will be flow through open channels or tubes that don't involve pores, just the open water. And then we'll have flow, but under laminar conditions, so low Reynolds number. And then we'll pick up the flow velocity a bit and look at how to simulate conditions that are turbulent. And then we'll also look at simulating multi-phase flows. So that's that's the overview of the different topics. Um, and I'm also open to suggestions for topics. We'll still keep flow, reactions, transport, and heat and deformation. But if you've got some aspects of these things that you would like to hear about, um, by all means, let me know. And that applies particularly to the examples. Okay, so we're going to use Canvas as the content organizer for this class. And the way that this is going to be organized is that we've got these modules here. So if you go to Canvas and you select modules, each week of the class has a module. So here's this week is this introduction, and then the fluid flow through porous media has a module, and within that module there are some notes, and there's PowerPoint. So the notes are a Word file. There's a PowerPoint that I'll use in the lecture, and then here's just some. This is a USGS report that gives some additional information, and then there's this stuff is related to the homework. You can also go to the homeworks directly if you go right here to assignments. But the main organizing structure within Canvas is these modules. The way this, well, okay, let me go to Canvas. So here's Canvas. Here's a module. There's the syllabus for the class that I handed out. Those are the notes that I handed out. I, the notes. It was a big stack of paper. I think what I'm going to do is probably not make the hard copies for you for the notes. All of these all these topics will have. I've gone through and written up notes in some detail about how the governing equations work and the mathematical aspects of it. And so those notes I'll give to you in electronic form, but I probably won't print them out after today. Let's see. The other thing here is that for each for the first week, there's going to be an example that we work on, an assignment. The way that this is set up is these assignments draw on a library of examples that I put together. So the library itself is here, and so here it is, the current version of the library. And so it's organized into various different processes: saturated porous media, unsaturated fluid. When I say fluid flow, this is just the flow through channels and conduits. Mass, and so various topics. And each one of these then is it goes to a page that describes. Got some text here and describes a problem. And yeah, so just fairly recently figured out how to do this animation in Canvas, so you'll see some of that. So it describes it, and then there's a video. So you'll go and read about it, and then take a look at this video. And these videos are going to walk you through how to do the analysis. We'll use a software package called COMSOL Multiphysics. That'll be really all of these examples that are shown here are done using COMSOL Multiphysics. So there would be other software packages that could be used, but COMSOL is pretty good at providing a platform for doing. Were really two things: a fairly broad range of simulations of different types of simulations, different types of processes, and it also gives you the ability to customize the simulation. So it does a fairly broad range, and it's easy to, or let's say, not easy. It's possible to extend that into to other processes. So it's a pretty powerful tool, and that's what we'll be using for the class. Um, there's files here. There's a bunch of files associated with the course. If you want to, a lot of them, a lot of the ones that I really intend for you to have are are here in the hyperlink, or here, like that thing is a hyperlink to someplace else. So you should be able to get all the files you need. But if you want to go rummaging around and look at a bunch of files, they're in there. Um, the the grades, yeah. So I think everybody should be in here. The grades will be posted here. Um, all of the homework will be submitted online. So they'll so what you should do is generate a PDF file of the homework. And what would be really great is if you if there are well, what would be really great is to just upload one PDF. So if you have multiple PDFs, if you or other software, uh, what would be great is to merge it together into one PDF. If you do that, then Canvas is set up to really facilitate looking through those fairly easily. If it's multiple ones, then I have to download them, and everybody every, everybody says like my homework is called homework 3, so I've got 10 different homework 3s that are downloaded on my computer, and it'll be a lot easier if you just use one PDF. Okay, so that is the aspects of Canvas, and so any questions on that? I think that will be good.